Hello everyone. In previous class, I discussed 15 questions of AP DSC 2025 questions. If you want, watch the previous video. Continuation of the previous video, 16th question I am going to tell you with explanation. The non-ferrous ore from the following. No, ferrous. Ferrous is nothing but related to iron. Related to iron. So non-ferrous means it should not contains any iron. It should not contain any iron. So here let us see what is siderate. Iron carbonate. Iron carbonate is called as siderate. Magnetite. Fe3O4. This is iron oxide. Hematite. Fe2O3. Ferric oxide. Malachite. Because why I'm explaining each and everything, no? Each and everything. What is magnetite formula from the following? In the next examination, you may expect. So if the concept is giving means from this concept in the next consequent years, definitely from there, one more question we can expect. So malachite. Is copper ore. CuCO3 dot CuOH twice. This is copper ore, which is also written as Cu2 CO3 OH twice, total combination of all this. So here this contains iron, magnetite also, siderate contains iron, magnetite also contains iron, hematite also contains iron. So here malachite is copper. That's why this is not non-ferrous alloy. Non-ferrous alloy is this one. So option is D. The element with least electron affinity of the following. Electron affinity depending on the size. Say for example, if it is small size, more electrons are attracted towards the nucleus. If it is very bigger size, so then what happened? Depending on that, here electron slowly attracts towards the nucleus because which is very far. See the amount of energy utilized to add one electron. To add one electron, the amount of energy utilized to add one electron is called as electron affinity. So in the electron affinity, adding electron to this, why? Because these are all strongly bound by this nucleus, is very difficult. So whenever size is very big, then it is easy to add the electrons into the outermost shell. Why? Because nucleus attraction is very less. That's why in this case, if size is more, affinity, electron affinity, electron require less energy to add. Electron require less energy to add. So if more the size, lesser amount is required. Lesser amount means least affinity. So here fluorine is smaller in size. Here atomic number of chlorine is 9. Atomic number of cesium is 55. Atomic number of chlorine is 17. Atomic number of oxygen is 8. So then what happened if atomic number more, size is also more. Whenever size is more, affinity is, electron affinity is very less. Easy to add the electrons. So the less amount of energy is required to add this. So affinity, electron affinity is less. So in this case, greater the atomic number, least is the electron affinity. Among all these, which one is the greater the atomic number? Cesium, greater the atomic number, least electron affinity. So this is the explanation of electron affinity. 18th question. Enzyme is used to convert starch into maltose. Starch into maltose which one enzyme is used. So now let us see all the enzymes. Here invertase. So in the presence of invertase, we have sucrose. Sucrose is converted into glucose plus fructose in presence of invertase enzyme. Here amylase. Usually amylase, in presence of amylase, starch undergo converted into simple sugars. Diastage. In this case, what happened? This diastase is used to convert starch into maltose. And maltase is used to convert maltose. Maltose is sugar. Maltase is enzyme. Maltose is converted into glucose. So in this, why I am telling all these things? No, these are all enzymes, but different category enzymes are there. So our starch is converted into maltose is nothing but diastase. So answer is diastase. Remaining are also very important. That's what I have explained all these things. See, in the presence of invertase, sucrose is converted into glucose and fructose. Sucrose converts into glucose and fructose. Which of the following enzyme is used? Likewise also, this concept is very important. The pH of solutions. 19th question. The pH of solutions A, B, C, D. We have A, B, C, D solutions are there. A, B, C, D. A is 11.2 pH. B is 5.3. C is 7.6. D is 1.4. These are the pH values of solutions. They are asking what is strong acid. Among all these things, what is strong acid? Before going to know this, we need to know what is pH scale. pH scale is nothing but we have a Mulliken scale, like pH scale is there from 0 to 14. We have values which in between we have 7. 0 to 7 acids. 7 to 14 bases. So 0 to 7 acids means slowly 1, 2, all these are very strong acids. Nearly 5, 6, all these are weak. We are moving towards 8, 9, these are weak bases. 12, 13, these are strong bases. So basically we are moving from acids towards the bases. So the value of 1.4 is here, 1.4. 7.6 is here, weak base. And then 5.3, weak acid. 11.2, that is also strong base. So they are asking what is strong acid. Strong acid is 1.4. 1.4 is D. So here the answer, finding answer is very easy, but choosing option is difficult. They are given like this. See, answer A is D. Answer is D. So what is the option of D? A. So here we have to choose this A. This is the answer. Likewise, they will give the confusion options, but you should be very clear. D is the answer. So option A we have to choose from the following. So A is the answer. Likewise, for simple questions, they will give complicated options. This is about the pH. This 7 is called as neutral. Next question 20. We have fatty acids are there, formulas are there. So now we have to find out. This is also like fact based. You have to know the formula of stearic acid. Usually stearic acid formula is C17. C17. Usually from we have to know ethanoic. This is ethanoic acid. Ethanoic acid means ethanoic acid. Ethanoic acid is nothing but eth means 2 carbons are present. Ethanoic acid. And among those through carbons, OIC means according to IUPAC, OIC means one carbon is involved in COOH. So C double bond OH or COOH we can write directly. Another carbon, how many bond it is? It is having already one bond, so remaining 3 bonds are hydrogens. This is what we call it as ethanoic acid according to IUPAC. IUPAC is a international standards to give the names to the chemicals. So here this is ethanoic acid. So easy to find, that is CH3COOH. Common name it is acetic acid. Acetic acid is the common name. Acetic acid is the common name. So here ethanoic acid is CH3COOH. So we can, D is Q. D is Q. These two options are not correct. So D is Q. Remaining two options we have to see. They are saying C is P. C is nothing but palmitic acid. See here, palmitic acid, stearic acid is C17H35COOH, which is saturated fatty acid. In the next exam, you may expect this question, which of the following is a saturated fatty acid? Stearic acid is a saturated fatty acid. Oleic acid, C17H33COOH. This is monounsaturated fatty acid. Monounsaturated fatty acid. Fatty acid is nothing but long carbon chain, 17 carbon, C like that, 7 carbon chains we are connecting with this COOH. That is what we call it as fatty acid. Fatty means lengthy carbon chain is present. This is also lengthy carbon chain, that is what we call it as fatty acid. Now palmitic acid, C15H31COOH, which is also again a saturated fatty acid. Saturated fatty acid. So these are the formulas. We must remember these formulas and their fatty acid nature also. So stearic acid is C17H35COOH. Oleic acid is C17H33COOH. Palmitic acid is C15H31COOH. So A is the S. A is S. D is Q. So this is the option. So option number 3. This is the answer. So this is the answer for those. Now coming to the following question. The following 21 is the 21 question. The following acid is a vitamin. Ascorbic acid is vitamin C. Vitamin C. So remaining are not vitamins. Adipic acid is used in the preparation of nylon. So in making of nylon we are using adipic acid. Saccharic acid, aspartic acid, all these are also not vitamins. So answer is ascorbic acid. Thank you.